Good morning, everyone. Your host, Golden Zulu. So, today we are going to look at what is referred to as integration by substitution, where we have four examples to guide us in how we can understand integration by substitution. So, with substitution here, you can just choose any letter you want, but specifically for me, I like letter U. So, we'll start by solving number 1, where we know to say it is requiring us to find the integral of 2x plus 1 to the power 4 dx. So we can say let 2x plus 1 be u. So immediately we do that, we now find the derivative of u. How do we do that? We can say u is equal to 2x plus 1, where the derivative of u in this case is du over dx is equal to 2. Immediately we find the derivative, we now make dx the subject of the function, where we know to say we will have du equal to 2 dx, where our main interest is to make dx divide both sides by 2. So we have du over 2 equal to dx. Then immediately now we have this. Remember, our main interest is to find the integral of this. So we know to say we had to let 2x plus 1 equal to u. So we'll say the integral of u to the power 4. Remember, dx in this case is now du over 2. Remember that in front of du there is a coefficient 1. So we can say let 1 over 2 be outside the integral, then you remain with 4 u to the power 4 du. Then we know to say the integral of u to the power 4 is u to the power 5 over 5. Remember, for you to find the integral, you can watch my previous videos. I already did the integration of any linear function or exponential function. Then from here we add the arbitrary constant c. Then from here we can just say 2 times 5 equal to 10. Then you know to say u in the first place was 2x plus 1 to the power 5 over 10 plus c. So this is the integral of 2x plus 1 to the power 4. So from here again we have the second example, which is x squared. Remember, this is a product of functions, where we get the complicated one, where we'll get the power of the exponent. So we'll say let x to the power 3 plus 4 be any letter, but in this case we'll let it to be u. So we'll say u is equal to x to the power 3 plus 4. Then we know to say du over dx is equal to 3x squared. Then from here we'll make the dx the subject. So we'll have du is equal to 3x squared dx. We want to make dx the subject, so divide both sides by 3x squared, also this side by 3x squared. So this will cancel and we'll have dx equal to du over 3x squared. Remember, our main interest is to find the integral of this function. Then we know to say the integral of x squared. Remember, we had to let the power of the exponent to be u. Then dx in this case is now du over 3x squared, where this squared and that squared can cancel out. Then you will remain with the integral of the exponent u du over 3. Remember, there is a 1 here, so we will take the 1 outside the integral. So we will take the 1 over 3 outside the integral. Then from here we now have eu du. Then you know to say the integral of eu is the same as eu itself. So we have 1 over 3 EU plus the arbitrary constant, which is C. But remember, the U in this case was x to the power 3 plus 4 plus C. So this is the integral of the function we were given above. So our third question here was this. We know to say we always get the complex one. So in this case, the complex one is this one. So we can say let x squared plus 4 be u, where we now know to say we find the derivative of u with respect to x. So it will be du over dx is equal to 2x. Then from here we make dx the subject, where we will just go directly. This time it will be du over 2x is equal to dx. Then immediately now we have this, we will just replace with our own dx with du over 2x. So we know to say our main interest is to find the integral of this function, where we know to say we had to let the denominator to be equal to u, where dx in this case is equal to du over 2x, where we know to say x and x can cancel. Then from here, so from here we know to say we had to cancel these x's. Then from here we can say 3, then we multiply 2 times u, that is 2u du. Then we know to say these coefficients, they can come outside the integral. So we have 3 over 2, the integral of 1 over u du. Then immediately we see such, we know to say the integral of every fraction whose denominator is raised to the power 1 is 3 over 2, the ln of u plus c, where we know to say u in the first place was x squared plus 4. So the answer here is 3 over 2 ln x squared plus 4 plus c, where we can just put the braces here. So from there we have our last example here, which is number 4. But number 4 wants us to evaluate what we have been given, coming from 1 going to 2. So we know to say we always get the complex one. In this case, the complex one is the